Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Chapter Basic Principles and Techniques in Organic Chemistry, and we are doing the topic Structural Representation of Organic Compound. Hello friends, now we are going to do a new topic, that is structural representation of the organic compound, and there are various methods on which we are going to discuss about how the organic compound can be represented in the form of its different constituents that are being present in it. So let's talk about that. So talking about the structural representation of the organic compound can be represented in several ways. Starting with the first one, that is structural formula. The second, bond line formula. The next is condensed formula. And the last one is Lewis structure for that organic compound. So in fact, this is not arranged in a arrangement of that is, we should always start with the structural formula, but yes, we could start with anyone. But let us talk about the first one, that is what is actually structural formula, that is a representation of an organic compound. So talking about the structural formula gives us the exact detail about the how many bonds are being present between the two atoms, as well as it gives an overall idea that what kind of the bond is been present in the between the carbon, hydrogen, or the other elements that have been present in the organic compound. So talking about the carbon atom is the one which is basically a tetravalent atom. So that is the reason that it forms 4 bonds. So when it forms a carbon single bond with as we can see in alkane, so therefore it shows that the carbon-carbon bond is basically single, and that's the reason that saturated bond has been formed, and that is the reason that the hybridization of the carbon in that case is basically known as sp3 hybridized. And this hybridization gives us the detail about the geometry of the molecule, as well as the bond length, as well as the bond strength of the bond that forms between the two atoms. So because the carbon, when it comes to an alkane, it is a saturated carbon atom, and that is the reason that it forms only single bond, and that carbon is the one that shows sp3 hybridization. But when it comes to the alkene, in alkene, that carbon shows the sp2 hybridization, making a formation of carbon-carbon double bond at least. And talking about the in terms of an ethine, that is the carbon forms a carbon-carbon triple bond with a in a molecule we could say at least one carbon-carbon triple bond in an alkyne, and that's the reason that that carbon is basically sp hybridized. And the structure is also very easy to understand when it comes to, that is sp3 hybridization, that the carbon atoms, it forms a tetravalent bond, as you know, that it forms 4 bonds, and that 4 bonds are basically carbon-carbon single bond or carbon-hydrogen single bond, so making the structure or the geometry of the molecule to be like a tetrahedral. While talking about that of the sp2 hybridized carbon atom, they form a basically a like triangle shape, and talking about the sp hybridization, they forms basically a linear shaped molecules, and that is what it gives us a very detail about the bond length as well as the bond strength. So this is all which we are going to see in this all things. And talking about the structural formula only, the structural formula gives us the detail that how much and how many bonds are being present between the two atoms. So starting with the first one, that is structural formula. For example, if we have or if we have to denote that what is the structural formula of an hexane, so therefore hexane is the one which has a molecular formula of, that is C6H14. So this is the molecular formula of the hexane, but that could be represented in the form of structure also. And in the structural formula, we represent every bond. So therefore, even that, and it is not necessary that every bond should be represented, but yes, we will try to focus on that. It will showcase that how many bonds are being present between the two atoms, or we could say that how the bonds are being arranged. So therefore, or how the atoms are being arranged. So therefore, we could say, because it is of hexane, so therefore we could have, that is carbon-carbon single bond. So therefore there is 6 carbon that could be arranged in a, that is in a straight chain, because I am saying about n-hexane. So that could be written as 1, 2, 3, 4, 5, 6 carbon atoms and 14 hydrogen atoms. So even every kind of bond can be represented in this form. So that is the reason that we are representing it with carbon hydrogen single bond everywhere. So basically this is the structural formula of the n-hexane, and let me tell you, this dash represents the electron, that is the electron that are being shared by the carbon and the hydrogen atom in this case. So therefore the mutual sharing takes place over here, and that is the reason a bond is being mentioned, and that's the representation. That is, this single dash represent a bond or the presence of two electrons between the two atoms and that are being shared when it comes to the organic compound. So that is the reason that we are now talking about the structural formula. Even this could be written as in this form, that is, I could write it as CH3 single bond, CH2, again CH2, again here also CH2, CH2, and ultimately I'll write it at CH3. So this is the structural formula that we have represented. So, and moreover we could see that it is an organic compound, basically an alkane. So therefore we write it in this manner, but when it comes to the geometry, it is not as like linear as we could see. So the shape of each carbon atom would be in a basic in a geometry of basically tetrahedral form. So that is the reason for a better representation. So we write it in a straight line, that as you could see over here, representing every bond that has been present between the two atoms. So that is the reason we have represented this one, that is the structural formula. So the next that I am going to represent about that is bond line formula. So let us discuss about that also. So bond line formula actually gives us the detail of the carbon atom as well as the hydrogen atom, but we don't represent it. Yes, we write it in the form of, that is in zigzag form, and when it comes to the representation of an hydrocarbon, that is or whenever it is a representation of an organic compound. So the zigzag form has been written over there, and we don't mention over the carbon atom as well as we don't mention over the hydrogen atoms also that are been involved in the organic compound. We only represent it in the following way that I am going to showcase you. So suppose if we have a molecular formula that is like this one, that is, suppose it's CH3 and somewhere around H7Br. So C3H7Br is the molecular formula that we have got over here, and for which we have to do a that is bond line formula. So bond line formula is basically written in a zigzag form. So therefore, because here it is, as you could see, that there is three carbon atoms that have been present over here, and so therefore, and suppose if it is a linear molecule, so therefore we could say that is it could be written in this form when it comes to that is representation in terms of an structural formula. So I could write it in this form, whether it would consist of, that is, C three carbon atoms over here, and among this one would be the Br. So therefore, suppose if the Br has been attached over here, so therefore the rest of the thing, that is, it would be CH3, and here it would be H. And here what we have saw is even the carbon has been fulfilled by its valency, that is it is a tetravalent atom. So therefore, if I have to write the bond line formula, so the first thing that we have to do is we have to represent in a zigzag form. So how many number of carbon that have been present in a straight chain? In this case it is basically 3. So therefore I could write in this way, that is, this will be the first carbon atom, this will be the second, and this will be the third. And in this case, suppose I have represented, that is, the carbon atom, and there is no mentioning of the hydrogen atom, but it is obvious to know that this carbon atom consists of the 3 hydrogen atoms because one bond has been formed over here. So after of the 4 bonds that a carbon makes, one bond is been formed with another carbon atom, so making that the carbon has the 3 valency left, and that is being satisfied by the hydrogen atom. So that is the reason we have only represented one bond over here, and that is the reason it is known as bond line formula. And talking about the second one, that second one is consisting of, or it forms 2 bonds between 2 carbon atoms. So therefore this is a carbon atom, even this is a carbon atom. So therefore 2 bonds are being formed, one bond is being formed with this carbon atom, while the other one to this carbon atom. And there is no representation of the hydrogen atom that we do in bond line formula. But yes, there is a heteroatom that we could see, and that is bromine. So therefore that bromine can be written in this way also. So this is a representation that we have did for that is a bond line formula. But here the bromine was attached to the secondary carbon atom. But what if the bromine is attached to the primary carbon atom? Means I am talking about this example, that is CH3, CH2, and CH2Br. So in this case, as we could see that there are 3 carbon atoms and one bromine atom, and that bromine atom is attached to the primary carbon atom, that is this one, and here it was secondary carbon atom. So I could write the representation of the carbon first, so therefore there are 3 carbon atoms that are being present over here, so I could write it, and they are also in a linear form, so therefore I could write it in this form. So 1, 2, 3 carbon atoms are being written over here. And talking about even this carbon atom represents the CH3 because it is the terminal carbon atom, while this carbon atom represents CH2 because the 2 bonds are being focused over here, so making it to be known as that it has been attached to 2 carbon atoms, while the rest of the 2 valency are being fulfilled by the hydrogen atom. And talking about this carbon atom is forming 1 bond, so therefore that is the reason that we could see 1 bond has been formed. But this could have been CH3, but as I could see that even the bromine atom has been attached over here, so therefore I could represent in this way by attaching a bromine. So now this carbon is attached to 2 atoms, that is at least when it comes to the bond length formula, that is one is carbon atom and another is bromine atom, while the rest of the valency are being fulfilled by the hydrogen atom, so therefore there is presence of the 2 hydrogen atoms that are being attached over here. So this is the bond length formula of the molecular formula, that is C3H7Br, and we could do the bond length formula of any case of any organic compound, and it is very simple to do that. And talking about the next one, that is I want to represent about what is actually condensed formula. So the third is condensed formula. So condensed formula is very much similar to that of the structural formula. The only difference is we don't represent that is a bond, or we usually represent a bond, or we could say as a dash between the 2 carbon atoms, or between the 2 atoms when it comes to the structural formula. But in condensed formula we don't represent it with a bond, and the only thing that it differs is not only the bond, but also that suppose if the groups are similar and that are be repeating, so that for we do is we make it condensed and we write it with a particular subscript, and we will take it as a common thing. So let me give you an example, that is the same hexane. Suppose we have took an example of an hexane, and the hexane has a molecular formula that we know as, that is C6H14. So if we have to write the structural formula, then let me remind you that the structural formula was being given as in this form, where we have represented with every bond that was being attached to each other. So this is what we have did this structural formula. But when it comes to the condensed formula, so we write it in this form. Either we could call it as a structural formula, or even this also, because there is a presence of bond, as we could see over here. So in condensed formula we don't represent the bond, so therefore we could write the N-hexane as CH3, CH2, 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 and CH3. So there is no representation of any kind of bond, and but you could see that one group is been repeating several times, and that is CH2. And we are not talking about the CH3 because this CH3 are the terminal carbon atoms, and that's the reason that cannot be included in that is while writing the condensed formula, and that cannot be included in this form. Suppose if I write in this way, that is CH3 twice, and the rest is CH2 that has been repeating 4 times. So this is not the correct method to represent, because these are the terminal atoms. This should be stayed at the terminal atoms only. So therefore I would write over here as CH3, while this repeating, that is the methyl group, that is CH2. These groups or methylene groups that are being repeating. So therefore how many methylene groups are, as you could see, that is 1, 2, 3, 4 repeating 4 methylene groups have been there. So therefore I could write it as CH2 with a subscript of 4, and then I'll represent by CH3. So now this is the condensed formula that we do, and here we have not represented with any kind of bond, and hence this was the wrong one, while this was the correct method to represent the condensed formula. And usually most of the organic compounds are being represented by not only condensed formula, but yes, they can be represented by molecular formula or structural formula. So this is a very appropriate method, but it doesn't give the detail, or we have to, because in this case we have to draw the structural formula, and then we could say that which kind of hydrocarbon it is, whether it is an alkane or alkyne. So depending on the structural formula we could decide. So even this is a correct method to represent a particular organic compound. So that is it is a condensed formula. So now talking about the last one, that is Lewis structure. Lewis dot structure, or we represent it commonly known as Lewis structure. Actually, this is the formula or the kind of representation that we do for a particular organic compound by representing it, the number of electrons or the number of valence electrons in the overall structure or in the overall formula that we represent. For example, let me tell you, that is when it comes to methane. So methane has a molecular formula that is CH4. Even this can be called as the condensed formula also, because the molecular formula can be CH4 as well, as while representing the condensed formula also it is the same, that is CH4, and we don't represent with any bond over here. So while talking about the structural formula, then the structural formula can be represented in this form, that is by representing the every bond that has been present in the organic compound, and with the representation of every atom that are been present, not like that of the bond line formula, that we don't represent the carbon atom as well as the hydrogen atom, but only we represent by zigzag line, and depending on that we could easily estimate that which one is the primary, secondary or tertiary carbon atoms, and that's the thing that we can do with the bond line formula. But the structure formula that gives us the whole detail, and that's the reason it is the best representation for an organic compound. And talking about this one, that is we are now going to represent about what is actually Lewis structure. So before understanding the Lewis structure, we should know that while formation of a bond, basically two electrons are being needed, and those two electrons are because it is forming a single bond, so therefore it will be because of a mutual sharing when it comes to an organic compound. So suppose if we are trying to represent the structural formula of the methane, so that is what we have represented over here. But talking about the Lewis structural formula, so therefore we could write it in this form, where the carbon atom is been present in the center, and the carbon atom consists of basically 4 valency, because as we know that the valency of the carbon is 4. So suppose we have represented it with the dot over here. So this represents the valency of the carbon atom. While talking about the hydrogen atom, even hydrogen atom has a valency of 1. So that is the reason that we could write it in this form. I've represented it with a dot, but we can also use a cross. So therefore, for dot and cross is the also known to be known as Lewis structure. So even the structure could be written as in this way, as I could write over here. That is, in the center it will be a carbon atom, while as you could see that this black dots are representing the electron or the valence electron of the carbon atom, while these red dots are representing the hydrogen electrons or the valence electrons of the hydrogen. So therefore, we could represent in this way when this is the one that a bond has been formed over here, as we could see over here. That is, one of them will be a, that is, it is formed like this one, that is, these two electrons will combine with each other so as to form a bond. So in Lewis structure we represent the electrons of, or the valence electrons of the atom. So it is very simple to write the structure of that. So I could write it with the simple a cross and a dot, and between this carbon and this there is this two electrons, and while again also here also I would represent it by a dot and cross. So now here it is basically the hydrogen atom over here. Here also I could represent the same way by representing this 2 and H. So this is the Lewis structure formula that I have represented it for the methane. So similarly we could draw the Lewis structure for, or Lewis formula for every kind of the organic compound. So based on this thing, that these 4 things that we have did, I have a few questions, and on regarding that we have to decide or we can convert that kind of formula to another kind of formula. So let me give you an example. That is, suppose if we have a condensed formula like this one, that is, so this is the condensed formula that we have. And why it is called to be condensed formula? Because here there is no representation of any kind of bond, so therefore this could be called as the condensed formula also, or the representation of that organic compound. Suppose we have to convert this into the structural formula. So how can we represent it? Because structural formula usually gives the detail about the bond attachment between the 2 atoms, and more even that is and it gives us a better detail about what kind of bonds that are been present, whether it is a single bond or double bond that has been present in the organic compound. So for example, if we are representing a structural formula for this formula, that is CH3 CH2 COCH3, it could be called as a condensed formula also. So for this I could write the structural formula as in this way, that is CH3 bond CH2. Again, a carbon has been present, but the carbon has a valency of 4. So in this, the oxygen is been directly attached to the carbon atom, as you could see over here. So that means if oxygen is the one that has been attached to the carbon, either the oxygen will form two bonds or a double bond with that of the carbon, or it could form a single bond with one carbon and another single bond with another carbon. So now, as you know that this is the one which is CH3. So therefore, I could say that the CH3 is the one which will have only one valency left, and that's the reason that CH3 will only form one bond. So therefore, I could say that there it is very easy to understand that the CH3 will form only one bond. But talking about this carbon atom has a tendency to form a 4 bonds, but one bond is been formed with this one. If one bond is been formed with CH3, while the rest of the 2 bond can be shared with the oxygen atom. And suppose if I would write the structure in this way, as it has been logical to be said, so where is the 2 valency? So that is the reason this is the incorrect method to represent. So that's the reason that's the reason that I was saying that structural formula gives us a better detail about the carbon-carbon double bond or carbon hydrogen or any kind of bond that has been present between 2 atoms. So therefore we could write the above structure as in this form, that is CH3 bond CH2 C, that is carbon. Now I could represent it by double bond O, then one bond, and then again CH3. So this is the structural formula that we have did for the above one. So now we have I have something more to do, and let us check that also, and it would be very much easy for us to basically know how to represent such kind of organic compounds when we have different kind of representations. So talking about the next one, that is, suppose if we have a representation of an organic compound like this one, that is, so this is the one that we have, and as we know that it is not there is no kind of bond that is been represented over here, so therefore we could call it as a condensed formula. But we could see that there are similar groups that are been attached or that are been in this formula, and that is CH2, which is repeating. So therefore for which I could write the condensed formula in this form, that is CH3. This 3 times CH2 has been repeating, so therefore I will write it here as CH2 and with a subscript of 3, and then later I could attach, that is Br. So now talking about the next, that is structural formula. Even we could write the bond line formula for this one, and even we could have written the bond line formula for the previous one, but we'll check that later on. But talking about this one, so suppose if we have to do the structural formula, so therefore it is very much easy, that is CH3 CH2 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 Br. Or else we could also do a representation of the hydrogen atoms that are been attached to the carbon atom, forming a single bond. So even that could be done. And talking about the next one, that is the bond line formula, because the 4 carbon atoms that are been attached in a straight row, so or in a linear form, as we could see in the structure, so therefore that could be written as, that is carbon number 1 2 3 4, and this represents the terminal carbon atom, while this is the CH2. Even this is CH2, and this would be CH2 with bromine attached to it. So therefore this is the bond line formula that we have made, and that's it, which I have represented. But yes, one more thing has also been remaining, so let us try this out and so as to understand this one. So obviously we have got to know that this is basically the condensed formula, and as we could see that there is no representation of the bond between the 2 atoms over here, so we have to write the structural formula for that one, and we'll see that how can we do the bond line formula for this one. So starting the first one, that it consists of the OH group that is been attached to the CH2, so therefore we have to represent the bond between them, so therefore I could write it as, and then CH2 that is been attached to CH, so therefore I would write over here as CH. But meanwhile, if you could see that there is a bracket that has been formed over here and the CH3 is been attached. So what does this indicates? This indicates a branch. Yes, so therefore I couldn't write it in a straight form because I have to write it in a straight form, but this is the one that is a substituent or that is forming a branch one, so therefore I would write it over at the lower position like CH3. So the work of this is been done, and then I'll move to the next one, which is CH again. So therefore there's a bond of CH, and again if I would have moved further, so therefore there is a bracket that I could see, so this represents another branching, so therefore I could write it over here as CH3. And moving further, I could get CH2, so bond CH2, and later CH, so therefore bond CH, and later I could see 2 times CH3 or methyl group is present. So that could be represented in this form, that is CH3, or else over here I could write it bond over here, or else I could write it over here as CH3. So this is the thing that we have did. So this is the structural formula that we have did for the above, that is and condensed formula. So the bond line formula is also very easy to understand, so let me give a glimpse of that also. So it consists of basically in a straight line, as you could see that 1, 2, 3, 4, 5, 6 carbon atoms are present in straight shape. So therefore I could write it in this way, that is 1, 2, 3, 4, 5, 6 carbon atoms are being arranged in a straight shape. And talking about the first one, the first carbon atom consists of the OH group that has been attached to that, so therefore I could write it here as OH. So let me name it as 1, 2, 3, 4, 5, 6. So this is the first carbon atom that we have got. This is the second, and in second carbon atom we could see that CH3 group is present. So therefore this is first, this is second, and we'll name it as CH3. And again on the third there is CH3, so therefore I would write it over here as CH3. This is the fourth, fifth, again in fifth there is CH3, so therefore. But we have represented with CH3, so what can we do? We have to give the bond line formula for that one. So that's the reason that we should write in this form, that is 1, this is for OH, and OH is not it consists of carbon atom, that's the reason we write it as OH. And that is the another one, that is this is the first carbon atom, second, third, fourth, fifth, sixth, and these are the CH3 groups. So therefore we could write it as a single vertical line over here as well as on here, and so therefore this is the correct method for the bond line formula. So this is how we have represented it. So similarly we can do it for a carbon-carbon double bond also, and then that of a particular any kind of organic compound. So talking about the another one, that is suppose if we have this kind of bond line formula, so how can we represent it? Because as we could see that the carbon-carbon double bond are being present, so therefore this is basically CH2. So therefore this is CH2, which is forming carbon-carbon double bond, and here the carbon is forming 3 bonds over here, making this to be having basically it is fulfilling the 3 valency. But talking about the 1 valency that is been left, yes, that would be joined with the hydrogen atom. And the next, again there is a carbon atom that has been attached to another carbon atom, which is forming a carbon-carbon double bond over here. Again the valency of this has not been fulfilled, so therefore that would be fulfilled by the hydrogen, and even this would be fulfilled by this one. So therefore this is the structural formula. So that is what I wanted to represent. Thank you friends for watching this video. I hope you have got to know that is what is the different kind of representation of an organic compound, and we have did a few examples of that too. So share this video with your friends, and yes, don't forget to subscribe to Ekeeda channel. Thank you so much.